Hey folks, welcome back to another video. Today we're looking at question 8 to 9, consecutive numbers sum. We'll be using a mathematical approach to solve this problem. So let's jump right in. Let's look at a couple of examples before we start coding up the solution. Given a number n, you can always represent it as this expression where you have sum of k and keep adding 1 and 2 and 3 till you have I minus 1. Let's look at a couple of examples. We have n equals 15 here, and then 15 can be written as a sum of 7 plus 8, where k is equal to 7, and you add k plus 0, and then k plus 1. And then you have 15 equals 4, 5, and 6, where k equals 4. And then you have 15 that starts with 1, 2, 3, 4, and 5, and then where you have k is equal to 1. So if you were to write the solution like this, right here, what we have, if you want to write that more mathematically, this would be the equation. It would be n equals k multiplied by I plus I multiplied by I minus 1 divided by 2. And the reason why we have this is because, let's look at this, right? Let's look at this term first, k multiplied by I. So we have k, and you're adding that I times. So that is k multiplied by I, and then this right here, this term I multiplied by I minus 1 divided by 2, that's a summation formula where everything up to x is equal to summation, let me quickly write this down, summation of x equals to sum of all of the numbers from 1 all the way up to x, can be generally written as x multiplied by x plus 1 divided by 2. And since we have I minus 1 here, that would be I minus 1 multiplied by x plus 1, that will give you I minus 1 plus 1, so I divided by 2. And if you were to rearrange this formula, you have this term right here that comes to the left hand side, and on the right hand side you have I multiplied by k. So what this equation is doing is that as long as this part of the equation is divisible by I, we know that there is an answer. So the entire basis of the solution is that we will start with a value of 1 for I and keep going and checking if the solution is valid. If it is valid, we increment the result by 1. If not, we keep moving on to the next value. So let's jump right in. Let's initialize the result to 0, and then let's say for int I equals to 1, you start with 1. Oh, and then here you need to do another trick. I'll tell you why that is. I minus 1 divided by 2 is less than n I plus plus. And the reason why we are doing this is because this equation, it shouldn't be 0, it should be at least 1, right? So this part of the equation should always be greater than 0. And for that to happen, k has to be always greater than this term that we have right here. And to make that happen, this is the reason why you're using that checkpoint. You're not saying I less than n, you're checking that this part of the equation is always less than n, so that the right hand side of the solution is greater than 0 always. Alright, so you have the for loop, and then you check, hey, let's just quickly just copy this from here, and then we say as long as this is divisible by I, if this is equal to 0, you would increment the result, and in the end you would just return res. Cool. So let's quickly run the solution, see if it's okay. The first test case passes, everything else passes as well. Awesome. So let's quickly look at the space and time complexity of the solution. The space complexity is 1 since we're not really using any additional data structure. The time complexity of the solution is square root of n. The reason why is because we're not iterating through all of the values until I, but only till the square root of I. which is less than n. So thereby it is n, the time complexity is of n square. Sorry, I meant square root of n. All right. Yeah, so if there are any questions that you have about the solution, please let me know in the comments below. If there are any questions that you want me to solve on LeetCode, also let me know in the comments below. Please don't forget to like, share, and subscribe. I would really appreciate that. See you all in the next video. Peace.